All right, welcome back. Here we are in 4-4 or 4.4, whatever you want to call it. And here's that little blue box. Those little blue boxes just kill us. Because this is the same as the one before. Hey, make sure you got the code that you had at the end of the last one. So to get ready for these, when we're done with this, let's just copy this code and save it over to a notepad so that when we get to the next one, we've got our code ready to paste in here. I did that, and I probably should have told you to do it at the end of 4.3. Pause the video, go grab your code from 4.3, dump it into a notepad or WordPad. Doesn't really matter, either one will work for you. And then come back. Okay, I'm assuming you're back, you got the code. Let's see, what is it that we need? Man, we need a lot of stuff, don't we? So, we've got up to iterations only. But at this point, we've got get item, set item, size, grow, and shrink that we've created. So let's go ahead and paste those in from our last exercise. Now, what are they wanting us to do on this one? Well, they want us to create an insert and a pop function. So let's start out with the insert one. To def insert. I know I need self. That's a given. What else do we need for insert? The insert method expects a position and an item as arguments. So I need position and item. Well, wait a minute. It sounds familiar. That's this right here. Position's the index and a new item. So let's take that, paste it in there. I'm not being lazy, I'm just being efficient. Okay. Now, let's say, what are we doing here? I'm going to say that inserts item at index in the array. A little comment there of what I'm doing. Now, beyond that, what else do they say? If the position is greater than or equal to the array's logical size, the method inserts the item after the last item. Well, let's see. Before I even get there, let's think about what's taken place in this insert. So, I've got an array. Let's not assume that the logical is 0. We know it is, but let's not assume that logical is 0. Logical could be 5, and the length could be 5. So if the logical is 5, the length is 5, can we insert anything in there? No. So Alright, what do we have to play with? I've got the logical size here. Alright. So I want to see this may be a little confusing because we're mixing and matching concepts and they're kind of flowing and can be a little confusing. So I'm going to put a conditional. I'm going to say if self.size is equivalent to the len. Now, if we go back to the chapter, in the chapter they went and made a big deal out of the difference between physical size and logical size. And I said, you know what? Logical size is the len. Well, in this instance, they're not looking at it that way. They're saying we created this space. It's, from when we've run it, it's got something there or nothing there. We're going to have values in this one. So, in this example, they're really wanting us to treat the physical size as the len. We'll say that is the case, at least at this point. So if physical and logical are the same, then you know what? I want this thing to grow. And we're going to call that grow function. So if this thing didn't have anywhere for us to do an insert, let's make room. So we'll try that, and if the index is, what was the condition they had? If the position is greater than or equal to, insert it at the end. Alright, so if index greater than equal to self.size, self.size is the logical size, so at this point we're hoping we got room. And we want to insert this thing at the end of the logical size. So that's where we're at now. We want to go figure out where this thing, we want to insert it into self.items. It's an array. Well, it's a list, but it's an array. And where am I putting it? Well, let's try self.size. Assign to that the value of new item. Now, this sounds a little funny, but let's look at it this way. Self.size is the logical length of, or n. That's n. Self.size is the logical, so it's n. It's the logical length, not the index. So if we start counting at 0, self.size should be the empty spot after the last index that's occupied. So that'll drop that in there. Now, I need an else. I'm going to say index equals max index 0. Come down, and what I want to do is if I'm inserting it not at the end, if where I have to insert it is not at the end, now I've got to put this thing somewhere in the array. The first part was, well, I'm inserting it at the end. That's easy. This else, it's not as easy. And for it, I need to do that walk to open up a space, if you will. So let's put a comment in there. Say that I'm going to shift items down by 1 position. And how I'm going to do that, I'm going to do it in a for loop for I in range self.size index, and I'm going to drop down 1 each time. So we're going from the end in. So this is what we walked through in that one example in the lecture for 4, the first lecture for 4. We walked through this conceptually. So now I'm going to say self.item, it's going to be the I, equals self.item I minus 1. So I'm shifting it 1. And I forgot my assignment operator there. So I'm taking what's in the one before the end, and I'm moving it back 1. And I'm going to do that until I get to index. So that's going to swap all those things item by item. And now shift now what I'm doing here, I'm going to add a new item, and I'm going to increment the logical size at the same time. So self dot items index equals new item, and we pop back to the else. Self dot logical size. I need to increase this by 1 plus equals 1. That doesn't mean I added space there. That means that my logical size n just grew by 1. I'm just increasing the value that I had here. I may have increased it along the way, but I need to make sure that it is the length that it's supposed to be. So every item that I drop in there to grow the size, that's where it goes, or what happens is I've got to increase that by 1. Now let's come down. We got one more. We're going to define pop. Pop's going to get self, and it also needs an index of what it is or where it is that we want to pop something out. So to pop something out, throw a comment in, and what are we doing? I'm going to remove and return item at the index in the array, and I've got a precondition and that precondition, where was it? It's up here. This is our precondition. Now, you know what? I'm gonna copy it from here, but we're gonna use this. There we go. So we've got that precondition. And what did we say up here when we had the precondition? If that, throw that error, right? Let's come down here on the pop. You can't pop something you don't have. And what else do we have? Make sure that it's within the scope of what we're dealing with. And we've got to have item to return typo there. So item to return is going to be self dot items index. That's what I want to get out. You're going to give me an index, and I'm going to go get that. All right. So I look in that index, I see what's there. I put the value of it in this variable item to return. And what do we got left? Well, we've got that whole thing that we dealt with before, shifting. Alright, let's shift items up by 1. There's 1 position in it. We're going to shift up by 1 position. Do I have that code where we shifted down? I do, right there. You know what? I'm not going to be lazy, I'm going to be efficient, and I'm going to copy that and see what can we do to make that ours for this. So my condition's still the same, but I don't want to reduce, I want to make it bigger by 1. I'm going to change that minus to a plus. Everything else we're good. So what do we got left? Let's come back to the start of this 4, and this is a little bit too far of an indentation. There we go. So I made sure I'm going to walk through them and walk those items one by one. So what it is that I'm getting out of there, I stored it in item to return. And then I'm shoving everything into those positions one by one to take up that space that I just emptied. Now, all right. Let's do a reset. But I need a comment in there. Saying what we're doing in here, so we've got some understanding when we go back and look. What were we doing there? I'm going to reset the empty slot to the fill value. So I'm going to say self dot items self dot size minus 1, because this thing's shorter. We pulled something out of it. Equals self dot fill value self dot logical size minus equals 1. Reduce the logical size by 1, the one I popped out. We're getting there. We still got a little bit to do. Now, I need to shrink this thing if I got a bunch of empty space, I need to shrink it. That's the best way to word it. So I'm going to say if self.size is less than or equal to the len, but you know, not the len divided by 4. And essentially what that means is if 3/4 of the physical space is empty, 3/4 or more of the physical space is empty, and len self is greater than self dot capacity, self dot, we'll call that shrink function we already created. Close that there. Self.shrink. So we called this shrink there. Let's back up. When it's all said and done, I need to send that item to return back. To whence I called this pop function. So we call this pop function right here in the shrink function. But we didn't pass it anything. We didn't pass it anything, did we? Well, I don't know if they're going to be happy with it. They'll change it on us when we go, but reset the value here. We got the precondition. Walked it. Let's see what it does when we run it. Well, I still have those same traceback errors, but it looks like it's running. Looks like it's running. Empty. We put stuff in there. We inserted something here. That did walk. We might be good on this. Let's go look and see. Wouldn't be the first time that it said, no, I don't like what you did. There it goes. It doesn't like something we did. What is it saying it's got a problem with? It says list index out of range. I'm on line 104. So right here. Right there is where it says I've got a problem. That's in my pop function. And for I, in range index, shift up one position. You know what? I've got to swap these around. I have to swap these around because I'm passing these values in wrong. Alright. I need to be shift items up by 1. I want the index, and then I want self.size -1. I passed these backwards. I reused the code, but I couldn't reuse it exactly the way it was because I've got those swapped around right there. Where is it that we're going? And okay, let's see if this still runs. Still runs. Let's see if this is happy with me now. It says no. But now we've got the issue a little further down on line 108. And that is down here on capacity, and it says len takes an argument, exactly one argument. Yeah, it does. Did I not? I gave it self. Oh, I didn't give it self there though. It tells us what the problem is, and it's just a matter of reading it and letting it click. And I'm quick to assume I've got a problem with what I did. After years and years of walking away and coming back and, oh, there's the issue. I don't have to walk away from my code as much to find the issue. But when it's telling me where the issue is, it makes it that much easier. Now it's happy. So that one's green. I got green. So we're good. We're all good with it now. Just the little issues that we had to get through. This one was far more complex than the prior one. If you aren't strong in object-oriented programming and not strong in navigating these structures yet, this could have been an issue. That's why I want to walk these through with you. Some of them take longer than others, but if you think about how long it would have taken if I wasn't here to walk you through this, it could have been just brutal. Especially if you had an issue in the prior code, you couldn't proceed to the next one. So with that said, now let's go on to the next one, 4-5.